with a scalar, a lot of times people use, you can say I'm driving 45 miles an hour. That's a scalar, just an amount associated with it. But if you say I'm driving 45 miles an hour due east, that's a vector, right? It's a magnitude plus a direction. So when we add up scalars, it's easy, right? They're just numbers. You just add them up. But when you add vectors, it's not quite the same. You can only add them up if they're pointing in the same direction. So you have to deal with that. Okay, so let's, for example, look at some how we would deal with an airplane moving through the wind, and how we would figure out the velocity of the plane. So what we've got is we've got a that's an airplane, and it's moving at, let's say, at 300 miles per hour, and this is its speed with respect to the air, and it's moving to the right or due east. And then we've got the wind. I guess I called it air over here, didn't I? I'll call it air here. And it's a tailwind, so it's moving at 100 miles per hour with respect to the ground due east. So the way we deal with this is we add the two vectors together. And we get out our ruler and our protractor, and we draw the first vector. And the length of the vector is proportional to the magnitude. So I'll make that 300 some proportional to 300 miles per hour, 3 units long. And the air, I'm going to add to it. So now I go out to the tip of the first vector, and I sort of view this as my origin now, and I can draw my second vector. My second vector is right there. And then the sum of those, I'll use red. So the sum so what I'm trying to find, I guess I should tell you what I'm trying to find, right? We're adding the vectors to find this velocity of the plane with respect to the ground. So we're given the velocity of the plane with respect to the air. We're given the velocity of the air with respect to the ground. And if we add those two vectors together, we can get the velocity of the plane with respect to the ground. Okay, this one's pretty straightforward. I think you all could do that, right? You kind of know that. If there's if somebody's standing on a truck that's moving at 10 miles an hour, and they can throw a baseball at 20 miles an hour, and you're catching the baseball in front of the truck, it's coming at you at 30 miles an hour, right? You add the two vectors together because they're both going in the same direction, right? It's easy. We just add them together. So let's make it a little more interesting then. It doesn't have to be going in the same direction, right? So now we'll have our airplane going 300 miles per hour. with respect to air due east. And our air, let's have it going, how about north? So what's going to happen to our airplane as it tries to fly east? What it's flying through is moving north, right? So it's really going to have a trajectory that looks something like the dashed line there, right? If you're standing on the ground looking at it, it's going to really have that angled path. So let's see. Oops. So you pick your origin over here. Get out your ruler and you measure off something proportional to 300 miles per hour. Point it in the right direction. That's our airplane. Then you move out to the tip and you make a new origin there. And you get out your protractor and your ruler and you draw the next vector. Question?
The air is with respect to ground, right?
The air is with respect to ground, yeah.
Okay. It's just a little bit. Okay.
I'm sorry. What did I do?
It's with 100 miles an hour by flow, so it's with respect to air.
Oh, thank you. Thank you. So that has a length of 100 due north. This has a length of 300 due east. And now our resultant, the sum of those two, we start at our original origin, and we end up at the tip of the last vector. There it is. And we get out our ruler and our protractor, and we can measure the length of this red arrow with our ruler. And we can measure the angle here with our protractor. And that gives us a rough idea of what those values are. Okay? So you could actually measure these, right? But we know how to get the exact answer because this is a right triangle. So if you're careful, and you draw nice and neatly and you make the scale large enough, you can get pretty darn close by using your protractor and your ruler. Okay, I think you're going to do that in lab this week. And you can see you get pretty close. In fact, if you watch an old movie about a naval battle, or I remember in, Hunt for Red October, if you've ever watched that movie, there's a scene where they've got this map out in the map room right of the sub, and they're literally drawing lines on it with their protractors and rulers and charting their path through some crevasse in the bottom of the ocean, right? Trying not to crash their submarine. And that's what they're doing, right? They're doing vector addition with pens and protractors and rulers. So you can do that and you get some pretty good results, but we can do it using our trig identities to get exact results, right? So in this case, it's a right triangle. It's easy. R is the square root of 100 squared plus 300 squared. Did I write that down somewhere? I get 316. And theta is the inverse tangent of 100 over 300. Is that right? And I get 18.4 degrees.